Welcome back, guys. Today is the first week, and it is the second part of the first lecture. Today, we will be talking about database systems. So it's our first lecture on topic. During the first lecture, we talked a little bit about the class. We reviewed the schedule, so if you didn't have a chance to watch the first lecture, I strongly recommend to watch it. It has a lot of informative details about the course expectations, and details on what we're going to cover during this course. So, if you're watching it in sequence, that is a second lecture for the course, so it's a class 2. So, I'm going to start the presentation, and today we will talk about database systems. Let me share the screen. Okay. And we are going to bring the presentation up, and we are going to start a slideshow. So here we are. All right, so today we'll be talking about the database systems. As this material is covered in chapter 1, so hopefully you guys had a chance to read or at least skip through chapter 1. If not, I would strongly recommend to at least look through the material in chapter 1. It's going to be easier for you guys to understand and adjust to the pace of this class and how we're going. But if not, you can try to watch the video. Maybe you can do it without reading the chapter. But anyways, by the end of this week, there will be an assignment. By Sunday, you need to complete first quiz. It's not a quiz, it's just a little write-up about your background, but it's due Sunday midnight. So it is posted on Canvas and available for all of you. Just like I said during the previous lecture, it's going to be the easiest 10 points toward your grade, so please make sure to complete it. All right. So today we'll be talking about the databases. We'll start from identifying what is the data and what is the information and what is the difference between those two. We're also going to look at the data information pyramid. Some of those of you who took 180 course, you should be familiar with this, so it shouldn't be a new material for you. Then we will talk about database evolutions, and the first step in the database evolution was file systems. So we'll talk in details about file systems. We'll talk about how file system functions, about different disadvantages of the file systems and flaws that those file systems bring, and about the database as a solution to majority of the issues that file system faces. Then we'll talk about main components of the database systems. We'll also talk about database system functions. And at the end of the class, we will review different types of the databases, and we will see how those are different. Also, we will identify the potential issues with database systems and how the database systems might not be a solution for certain problems that we can solve easy with file systems. So just unlike both file systems and databases have their own advantages. So we're going to talk about how each one of them solve different potential business problems. And again, file systems are not dead. They still exist, and a lot of large enterprises are using it. So, for example, a company that I used to work about 7 years ago, no, actually 10 years ago, called ICW, still heavily relates on file processing system. It's an insurance company that does non-preferred insurance. So every night they have a batch process that fully runs on the file processing systems. So file processing systems are not dead. That's a wrong assumption. They have their disadvantages, but for some business cases, they are very decent solution. Right. So let's start. And as a start, we're gonna look at Susan's day of life. Susan, like any other person, does a lot throughout her day. Um, you guys probably saw. Oh, my God, something happened. So you guys probably saw this picture before. If not, during your 180 class. If not, let's review this in detail. So Susan starts her morning from grocery shopping, where she goes to the store and buys some food. So a couple of questions. Where are the product data stored? So she gets to the cash register. Where the cash register gets the product data? How do we know if the product quantity and stock is updated at the checkout? Does she pay with cash or a credit card? So all this information is going to go or through the database management system or going to be retrieved from the database management system. So for example, when the customer does a checkout terminal, access product database to identify the product price, also to update the quality in stock to make sure that future supply specialist knows when order the product when the stock quality goes low. So here's a database behind grocery shopping. Later on, Susan goes and picks up her prescription from the pharmacy, and same situation happens here as she picks up prescription. The pharmacist does her checkout, and during the checkout, the system interacts with inventory data. So also same happens when we need to retrieve the product unit price or product cost. So we also need to update our product inventory, and that's all interaction between checkout terminal and product database. So again, behind this process in pharmacy sits database with products, sales, and customers. Then Susan goes home and does some online shopping. We discussed this online shopping in details during the last lecture. So similar to grocery shopping and pharmacy, there is also product sales and customers database behind every online order. Um, Similar situation happens when Susan decides to book some airline tickets and hotels. So every system that Susan interacts with deals has a database on the back end. So there is flights database, hotels database, in some cases customers database. Um, and in the evening, she checks her social media accounts, and the same situation with social media accounts. Every social media platform has a database on the back end that has user information and stores posts for users, potential connections with other users, friends, and so forth. So as you can see, every aspect of this girl's life and every action she does during her day has a database behind the scene. So good thing about Susan, she doesn't have to work. So as you can see, she does everything besides work, which is not a lot of us can afford nowadays. So this image is a representation of the importance of database in our life. So let's talk about data and what kind of data is stored in the databases. But before that, let's review what we learned during the last lecture. So data are raw facts, figures, symbols that is in unprocessed form. So those are raw facts that exists in the world. Uh, Data can be in different forms, just like we discussed. It can be numeric, text, image, audio, video, geospatial data, and so forth. Um, when we store data in the database, data is transformed into a structured collection of data. Again, data are raw facts, but when we put data in the database, it becomes a structured collection of data. Okay, database management system is a collection of software, processes, procedures, and other aspects that allows us to, as users, to interact with the data stored in the database. Um, Database management systems help us to create and manage the data that is stored in the database. We talked about that a lot during the last lecture. Now, that was a review of the last lecture. So from now on, we're going to start a new material. So what is the data and how the data is compared to the information? So let's look at this image. What you can see here. This is data, raw facts. What is this data? What does it belong to? What are those numbers? So at this point, your guess is as good as mine. It can be anything. It can be flight numbers, phone numbers, can be just random collection of numbers. So looking at this data, we can just guess what this data belongs to. Let's look at this image. So now we have the same data, but this data is, we know that this data is part of something larger. And this something larger is a class roster for a specific course, MGT 500, which calls business policy for a specific semester and for a specific section. And this data is nothing else than ID for the 6 students listed in the column called name. And those IDs, each of them belong to one student. And each student has a major and associated GPA. So this is data in context. So again, the difference between data in context and just data, data in context gives us meaning. So unlike the previous slides where we have just numbers and nothing else, this is data in context. So this data has a good meaning for us. So context help us to understand the data. Let me minimize that. How do I minimize it? Okay, so I think I can move it now. Here we go. Um, I don't know if you want it to open or not. Where does it go? Anyways, so data helps us to understand the context help us to understand the data. So again, like while data is raw and processed facts, figures, and details, data in context is actually gives us understanding of what it is. Now, um, that was unprocessed data, okay? It was data in context, but it's still unprocessed data. So it doesn't help us anyway in making any business decisions, assumptions, or improvements. So what is it? It's just a list of students for a specific major, for a specific class, for a certain period, for a certain time frame, right? In this case, semester. So, do we know if this, for example, specifically student Baker GPA improved or it went down? We don't know. What is the class average? We also don't know. How the class average changes from one semester to another? We also don't have this information. So, even data in context is still raw, while context help us to understand data, but even data in context is still raw and processed data. Now, let's look at summarized data. Summarized data increase data meaning. So it helps us to make better informative decision. So in this case, if we look at the same data, so we know, for example, this is a data for the entire major percent enrollment by major in 2010. So we know that 20% of all the students were in management, 15% in marketing, 25% in accountant, and so forth. We also can compare number of enrolled students per year. And here we can see that, for example, if in 2010, this number was closer to 300, it's almost three times more than it was in 2005. We can also see that enrollment by year has different trends. So at this point, uh, college can look at this data and make different business decision depending on what it's using it for. So, for example, do we need to go to schools and bring more students for the next year? Or if we are going to have more applicants, do we need to hire more instructors to be able to support this number of students? So, stuff like this can happen, can allow us, summarized data helps us to make decisions like this. So this brings us to the second definition called information. Information is a data processed to increase our knowledge, the knowledge of the person who is currently using the data. So that's information. Information is summarized or processed data. Okay. So now here's a graphical display how we turn the data into useful information that can be used to make business decision. Okay. So now let's look on how our brain transforms raw data into the information. So we start from raw data, and raw data would be on the very bottom. So that would be red, and then some geocoordinates, right? And VO2 is probably a version number of something, right? So based on the common sense. So we have geospatial coordinates, we have red, and we have a version. What does it mean? So raw data is data without meaning. Further down, we have an information. So information is a data that has meaning. So in this case, that would be a south-facing red light on the corner of two streets that just turn red. So that is something that our brain can process to gain knowledge, which is the next transformation of data. So data, summarized data transforms into information, and further down, information allows us to gain knowledge. And in this case, that would be the traffic light that we're driving toward has just turned red. And the next step in our brain, here comes wisdom or decision making. Different data pyramids called it differently. In this case, it's wisdom, and that's where our brain makes a decision to stop the car because it's a red light. So here we have it. Raw data into information transformation pyramid. Again, for those of you who took 180 class, you probably seen this diagram before. Now, that is how our brain works. Let's look on how different tools help us to transform raw data in the information. And we're gonna look in the easiest example using Excel. So we start into entering data for Middle Tennessee State University. So that's first data entry screen. That's where we put information into the system, okay? So we enter every piece of information, and that's data. So, well, combination of this raw data will be entered into the database table. So here's a database table that has all the Middle Tennessee State University students. It also has some grades, some email addresses and stuff like this. You can't clearly see it, but you get an idea. Okay, so we start from data, then we get to the summarized data, but still raw data here in image B. Now, when we combine the raw data into summarized format, we can see much better representation of this data. So, for example, we know that we currently have 5 adjuncts, we have 2 assistant professors, we have associate professors, instructors, and professors. So now we know what is the percentage of each, because we summarize raw data into a combination of those groups. In this case, we group by a specific rank. So again, like we start from data entry screen, we get into the raw data, and we ended up summarizing this raw data into information, which is data in the summary format. Further down, we get a graphical representation of this data, which helps us to visually see what kind of rank has how many how many employees related to this rank. So again, that is information, but it's in a visual format, and both C and D images allows business to look at the summarized data and analyze it. And again, like you can do multiple analysis based on this data. So for example, in this specific case, maybe college is trying to um, move toward hiring more instructors and minimizing the number of professors. It's rare case, but that's possible. Maybe they're trying to get rid of instructors altogether. Maybe they will offer all of them um, adjunct or associate professor positions. So stuff like this. Again, summarized information or just information, allows business to make business decisions, unlike raw data that just exists in raw format and is not capable to give necessary information to business to make those business decisions. All right. So that was how we transform raw data in information in the program. In this case, it's Excel versus our brain, a little more complicated in Excel, but the concept is the same. So when it comes to data in organization, it can exist in various different forms. So data can be unstructured, that is a data that exists in its original format. So for example, text files, emails, social media posts, voice, images, videos. So you can see all of those on the top three images. Data can be semi-structured. That is a data that has already been processed to some extent. So, for example, JSON files, HTML documents, log files. So, for those of you who took programming courses, you guys probably are familiar with JSON format. That is a very widely used format for writing web services. HTML documents are HTML pages. All of you guys at some point looked at different HTML pages. So HTML is behind every document you find online. So that is displayed in the browser. For those of you who took 180, you did create your simple HTML pages. And another example is the log files, log program activities. It can be a software program activities. It can be log file for Windows operating systems that logs everything that all the actions that user performs on the computer, stuff like this. So JSON files, HTML documents, log files, those are examples of semi-structured data. And we also have a structured data. Structured data is a result of formatting unstructured or semi-structured data for storage. And example of that would be SQL tables. You can see it on the bottom. That's a student data table. Relational databases it's a collection of those tables. And we're going to talk in details about relational databases in our next class. And XML documents. XML is also hyper markup language format. XML is widely used by businesses to move different data sets and describe different data sets too. So those are different forms of data in organization. Now, there is also metadata. Metadata is data about the data. So, for example, here we can see student table example from our previous slide. By the way, what kind of data represented by SQL table? Structured, semi-structured, or unstructured? Pause the video. Think for a second. All right, I hope you answered structured because that's what we just learned. Structured data, you can see on the bottom, it says SQL tables. All right, so we can see a student table here, which is a structured data. It stores student information, student ID, first name, last name, age, enrollment date. Now, here's the student metadata. So metadata describes what kind of data we store in a certain data, a certain database, or a certain file, or any certain storage. So metadata allows us to set a description and properties and characteristics of a specific data type. So in this case, we have five different columns in student table: student ID, first name, last name, age, and enrollment. And each one of those columns store a specific structured data, because again, we talked about SQL tables. SQL tables store structured data. So column student ID will have an in data type. First name is varchar, last name is also varchar. Varchar is just a character or a string. So also we have an information whether it's nullable. So can we store nulls and excuse me, for student ID we cannot, for the rest of the fields we can. So metadata is data about data. Now let's watch a really quick to just split me in my tokens. So let's watch a very quick video about what is metadata. God, hopefully it's gonna end. All right. Oh, oh. All right. So we just finished watching the video. I absolutely love Sarah, so I've been to this museum, so that's why this specific painting and the specific explanation is really good. I like it. Um, all right, so now we understand that metadata is data about data. So there is a structural metadata, there is administrative metadata if you go into the detail, but the main takeaway is metadata is data about data. Okay. So we talked a lot about different data types. We talked about data and we talked about structured data and how structured data is stored in the databases. Unstructured data can also be stored in the databases. We will talk about that when we'll be talking about big data databases like Cassandra, DynamoDB, MongoDB, and stuff like this. But for now, for the next 7 or 9 lectures, we will be talking about structured data that is stored in the relational databases. But before we talk about the databases and all the beauty and advantages of the databases, I want to go a little bit back into the history and tell you how in the past, some 20, 30, 40 years ago, we used file processing systems. So file processing system was used to store different data types. We also wrote programs that allows us to communicate to those file processing systems. So we wrote different software programs and routines that allows us to retrieve data from file processing systems and store data in the files in file processing systems. Okay, so what is file processing system? File processing system is a way to store and manage individual files on the file system, where each of those files operate independently of each other. So, for example, you can have Excel files, you can have CSV files, text files, so any type of files that combined together store information for a certain subject, certain area of the expertise, certain business department, stuff like this. So, the way we access the data from the files processing system, we need to know the path. So, for example, it can be stored on C drive. In data folder, we can have student text files. So, files have attributes. Remember what attributes are? This is a metadata, right? Data about data. So, those attributes include size, dates, file type, and other file-related information that describes specific files. And users must know how to manually organize those files and how to build relationships between those. So down here we have a diagram of file processing systems for a company. So by departments. So we have a billing department that has a program or billing software that access customer file and account receivable file. We have a purchasing program that also deals with different sets of files. So buyer file, inventory file, vendor file, stuff like this. So we also have account payable, sales, and payroll. So you got an idea. Every part of the company or every department or group of departments in the company or in the enterprise have different versions of certain files, and there are routines to specific to those files to access data from those files. Now, um, an example of a file processing system for Pine Valley Furniture Company. We'll be looking at a lot of examples for Pine Valley Furniture Company. So those slides are from Pearson Book. So while we're not using Pearson Book, I still absolutely love their images. So I have a permission to use them. So here's a first introduction to Pine Valley Furniture Company for you. This company has three different departments, and those different departments use different programs to interact with the data files. So as you can see that orders department has order file systems that deals with customer master file, inventory master file, back order file. Invoice system also has its own inventory pricing file and customer master file. As you can see here, so both departments have their own customer master file. And payroll department. Payroll department has an employee master file. So again, like three different departments with different programs, with different systems that has different or sometimes same named files that are used by those systems for each department. Okay, so this is an example of file processing system. As we looked at the previous image, you probably saw some similarities, and with those similarities of the data file names, it's clearly represents one of the problems that file processing system presents. So there are other problems. First and most important, first is the biggest problem is the structural and data dependence. So all the programs that utilize data files must maintain metadata for each file they use. And we remember that metadata is data about data. So all the programs for a certain department needs to know file metadata. They need to know how the file is structured, where it lives, how the data is organized in the file. That's called structural and data dependence. So there's also duplication of data or data redundancy when the same data is used by two different departments, but each department stores their own copy of the same data. Limited data sharing comes with file processing systems. So, for example, if the billing department needs to share information with accountant departments, they need to give them a copy of their own file, and now two departments will have the different versions of the same file, which will also not only cause data duplication, but also cause other issues, which we'll discuss when we'll talk about limited data sharing in details. So also loan development and processing time for file systems, because each programmer must develop a specific program and specific format for a specific file. And again, when file structure changes, those programs all need to be rewritten. So program maintenance also for file processing systems, they're very heavy maintenance. So if the routine needs to be rewritten. It takes a lot of efforts. And again, as business shows, so 80% of the information budget systems go into support and file processing system. So there's much more issues with file processing systems, but we're gonna look in details in structural and data dependence, duplication of data, and limited data sharing. And the rest of them, you can read more information in the book, but exam or test will only cover first three. So this slide is a little bit long, but it's very information heavy. So we're going to talk about structural and data dependence. What does that exactly mean? So data dependence means that all the data in the program, when data in the program are going to change, all the routines and programs that rely on that data must change too. So each programmer has his own metadata. They maintain their own version of the file. And again, every routine must change if data in the file is going to change. So that's data dependence. Structural dependence is when you change the structure or of the file, all the routines must change too. Very similar to the data dependence, but in data dependence, you change the data in the file. In structural dependence, you change the structure of the file. So for example, you have files that has, say, for example, 5 columns. If you replace first column with this, if you switch first column with the second column, all the programs that access the file needs to be changed too, because first column or first position of the data is going to have a completely different meaning after after the structure of the file change. So access to the file depends on its structure for structural dependence, and if the file structure changes, all the programs must change too. So that is data dependence and structural dependence. Now, our goal is to have data independence and structural independence. And here is what structural independence is. So it exists when you change the file structure. You don't need to change any programs that access this file. This is very difficult to achieve with a file processing system because, again, file structure defines the programs and how they access it. Data independence, similar to structural independence, it's when the data is changed, the routine that accesses data can remain unchanged. This is very important piece of information. This information is going to be on exam and on quiz. So please take a note of this slide and please keep it in your thoughts when you will be preparing for midterm exams. Structural independence and data independence, and structural dependence and data dependence. Those are very important definitions. We will be talking about those definitions a lot in this course. Both structural independence and data independence are provided and supported by database management systems. So those problems of file processing systems are solved with introduction of the database management system. Now, here's an example of data redundancy, another problem with the file processing system. So we have two departments, in this case, accounting department that has a customer master file. We also have an order department that has another customer master file. In file processing systems, there is no way for us um, to check if those files are the same, because each department keeps their own version of the data file. So that is data redundancy. Data redundancy means data duplication. So it's another definition for data redundancy. Well, with data redundancy, it takes more space. It's not a major issue because you guys know that storage nowadays is really cheap. So, but still, I mean, we can use this space for something else. So, well, here comes increased efforts to keep files up to date, just like we talked. So if one department update customer master file, there is no guarantee that other department will update the same file too. Uh, and also, it's important to note that the format of those customer files for two departments can be completely different. Again, because this file format, there is no standard file format for a file processing system, and in this case, have different format of two different data files compromises data integrity. Okay, so various issues, data redundancy brings additional issues listed here. This is also very important. This information will be on exam. You will need to clearly understand what is data redundancy. Now, data values may not agree, but again, that's another example of data redundancy. And we're going to talk about a little more about data redundancy. So here's a definition. Data redundancy exists when the same data is stored in multiple places, and the important thing are results of uncontrolled data redundancies are data anomalies. So data inconsistencies, data errors, data integrity problems, all of those called data anomalies. And I want to talk in details about data anomalies, because data anomalies are the major problems, cause major problems in file processing systems. So data anomalies is the main problem that was solved by introduction of the database management system. Data anomaly developed when not all the required changes in the redundant files are made successfully. So, for example, if one department modifies customer file and if the routine that update all the customer files exist, and if they don't fully run, or if the updates need to be done manually and they're not fully executed by humans, that is what caused data anomalies. There are three different types of data anomalies, and those types are tightly coupled or very deeply connected to the manipulations that we do with data. So when we think of what do we actually do with data? We can update data, right? We can add more data or insert, in database terms, insert data. We can also get rid of the data or delete data. So based on those three main actions that we perform to data, we have three different types of anomalies, each one representing one action that we can perform today on data. So update anomaly is related to the data updates. So update anomaly means data inconsistencies that result from um, data redundancy or partial update. Insert anomaly is when we insert data in one place but don't fully insert or completely miss the adding data to another place. And deletion anomaly is very similar uh, to anomalies that we discussed before. So that's when we delete the data from one place and we don't delete the data from the second place. In this case, two different data files. Okay. Um, so here's an example. So for example, we have a student data. Here we have five students and we added um, uh, we added a sixth student and this student, when the student is deleted, we don't only lose data on the student, but we also lose more information. So in this case, we lose department name, department code, and head of department. So the entire data set is lost. Limited data sharing, self-explaining. So that's when departments, don't share the data with each other. So, for example, in this case, when accounting department need an employee master file, it can simply use the same file as payroll department is using because again, processing routines and processing systems are different. So, accounting department just need to maintain their own version of master file. Same for back order file. If accounting department needs back order files, they will need to have an additional copy of the back order file for their own department that will cause data duplication, data redundancy, and potential data inconsistency. Other issues with file processing systems, so long development time, getting difficulty on of getting information quickly, lack of security and stuff like this. So, um, file processing system has various issues. It was the first attempt of storing the data in a certain format. So, in order to solve all of those systems, we can use a database approach. So, database, as we know, it's a way to store data in one centralized location. So we have a controlled data access, we have a standard file format. So all of the issues listed above that we discussed can be easily solved by introducing the database management system. But when we implement database management system, we also need to implement all those access routines for specific for the database management system. Now, let's look a very quick video about database management system and then we'll talk about database management systems in more details. Come on. Every video has a commercial. So this is a little comeback to you guys. So we are going to have a review of data and data types, but that's helpful. Right. So hopefully that was helpful. So let's get back to our lecture and um, we will talk in more details what is a database management system. So a database management system is a software that is used to create, maintain data and provide control to use databases. So database management system, in this case, allows to manage resources like in our case, operating system manages hardware resources. So here you can see file processing systems, three different departments using different versions of different files. In case of database system, all three departments are utilizing database management systems where employees, account information, customer and sales information is stored in one um, organized place, one database that is used by the same company. So let's talk about components. So every database system has multiple components that support this specific system. So it includes hardware, as you know, hardware is a computer or a group of computers where we store, in this case, data for the database. So every database management system needs to live somewhere and needs to be installed on something. In this case, it's hardware, can be specific hardware for the database, can be generic hardware that is computer that is used as a server. But again, like I mean, we need metal to store the database. So in other words, motherboards, computers. Um, there is also a software. Software, it's a list of programs combined together that allows users to access the data in the database. Well, obviously, those are database management people needs management system needs people who utilize and manage data in the database. Well, with people comes procedures that are used to get data from the database. And again, those procedures are defined by people, and procedures are different depending on the database management system engine we are using. There's also data access language, and in this case, common language understood by all the databases is SQL. However, SQL only works for the relational databases, and relational databases store structured data. When it comes to non-structured data like images, texts, audio files, different files that exist in unstructured format, those can be stored in big data databases, and every big data database has its own proprietary language. So, for example, language that works for MongoDB is not going to work for DynamoDB. So, again, database management systems like people, they have a certain language that is understood only by this specific database management system. So, for example, like people in France who speak French, not all of them understand English, while people in England or United States or Australia or other countries that speak English can understand English, but some of us might not understand other languages. So similar to the database management system, so every database management system speaks specific language, and all relational database management systems speak SQL. So hopefully by the end of this class, you will also have some speaking level of SQL that you can add to your resume. And obviously, every database management system stores the data, so data is also part of DBMS, and it's also a DBMS component. All right, so here is a combined diagram. You can read it in any possible way you want. I'm going to start from the database utilities or the database management system on the bottom. So as you can see, database management systems has hardware, and it's accessed through the software that sits on a specific machine. So you can see a computer here. So here comes multiple people or group of people that use database or that's where we have users on one side. There's also another group of people that is designing and managing the database, and those include system administrator who manages the hardware. We have a database administrator who manages the software of the system and the data. We also have a database designer who designs the databases for us. So prior to the database to exist, it needs to go through the design phase when we create initial design for the database, and then based called entity relationship diagram. It's a high-level design that is further down adjusted and go added details during the logical stage of database development. So on the database user side, we have end users who use the database. We also have programmers who create application programs, and we have a set of procedures and standards that are defined by database engineers, designers, and administrators, and that are used by users to access data from the database. And again, like application programs allows us to access data from database management systems, and um, both end users and programmers create application programs, but end users in this case utilize application programs. Important slide, please spend some time, try to understand it, and it gives you very detailed information who does what in the database management system world. All right. Database management system functions. So data definition, we create and modify or remove database structures such as table, indexes, or views. So again, like this is the main function of the database management system, data definition. Data manipulations allows us to retrieve or insert and delete data from the data structures. Data security that allows users to access the data from the database systems. It also prevents the users who shouldn't have access to the system, or unauthorized users from accessing the data. Data integrity, make sure that the data is accurate and consistent across the database management systems. Concurrency control is another function that ensures that we can access the same data multiple times by multiple users without interrupting each other. Transaction management, every database supports transaction processing. We'll talk more about transaction processing in class 11. So majority of the database transactions happens simultaneously on the same database, are supported by ability of the database to have a transaction management. So database is able to queue different transactions, execute different transactions at the same time, and make sure that results of each transaction executions are concurrent for the next execution. backup and recovery. So database management system allows us to back up data and restore data when needed, and data independence. We talked about data independence a little bit a couple of slides ago. So data independence is ability of the system to um, change the data without changing processing routines. In this case, without changing schema. So those are the main database functions. Also important part of the class, specifically of this lecture. Please pay attention on this slide and previous slide. So it's total of uh, 8 different database functions. Very important to know those. This information might potentially be on exam or tests. Okay, so we are getting very close to the end of this lecture, so we are going to talk about different types of the databases, and then we're going to talk about why databases might not be ideal approach for every situation when we need to store data. And that would be it for today. So let's talk about different types of the database. And first, database can be single user versus multi-user. And there is a use case for both of those. So single user database is self-explaining, allows only one user at a time to interact with the database. An example for the single user database can be Microsoft Access, and you probably all have question why in the world a single user database exists. Who needs a database that can support one user? Believe it or not, there is a lot of use cases for one single user database, and the main use case are proof of concepts. So sometimes we need to develop quick, dirty, and easy database to see if our specific proof of concept approach works. So we don't have time to implement a database engine, but we can use Access. So Access is a fantastic development tool for proof of concept. So we create when we need to create a proof of concept and we need a database for that, Access is a fantastic tool. Okay, you can also use Access databases for maintaining your personal data. You can, for example, have a database of your personal library, of the tools that you're using. So anything you need to store for personal use that you don't want to utilize full large database. Microsoft Access can help you. And obviously, multi-user databases support multiple users that can access data simultaneously. So single user database and multi-user database. A single user can also be used for small businesses, personal projects, rapid development, prototypes. It's also a very good option when you don't want to pay for a full database management system and you have a specific budget for the project you're about to implement. Okay. Um, Another type of database is centralized versus distributed. So centralized database uses stores data in one location, while distributed can store data on different nodes, different servers. So, for example, large companies usually use distributed databases where Some pieces of data can be stored across multiple servers, sometimes across multiple countries, across multiple continents. So depending on business structure, business need. So there's another version, cloud database. That's when cloud database is a database that is hosted on cloud environment, AWS, Azure. So you can store your database in the cloud. So for example, my team at work, we use a database server in AWS cloud environment where we store our database on one of our database servers in the cloud. Um, we actually have a lot of databases. I think we have total of 17. So centralized versus distributed, and cloud is another example. Cloud can support both centralized and distributed. So you can store data on different servers on the cloud. You can also store data in one location in the cloud. So in this case, it's going to be a centralized cloud database or distributed cloud database. By database, by stored data types, general purpose databases, discipline specific, can contain data on for a specific subject. Operational databases that are designed to support company day-to-day operations. So, for example, DynamoDB for Amazon, that's a database that is used by Amazon to support their daily retail activities. And also analytical databases that store a lot of historical data for analysis purposes. So example of analytical database can be Ancestry.com, where there's a lot of information about different people's past relatives. Okay, so we talked about the databases, we talked about components of the database systems. Hope you still remember those. You can pause this video for a second and remind yourself. All right, I hope you guys remember that we have hardware, software, data, processes, procedures, people that are main component of the database management system. Now, let's talk on how to create database management systems. And those are the main steps. And the reason why I wanted to bring those steps is because they um, pretty much represent what we'll be learning in this class. So we will be learning on how to create database from scratch. And that is very important to understand. So every class we have, starting from the next class, will be part of database management system creation. So we start from analyzing requirements and creating business rules. That is the first step of creating database. That's where we set all the business requirements for our future database. What kind of data we'll be storing in the database, what kind of rules we have, how different parts of data interact with each other. So again, first step is in creating database is analyze requirements and create business rules. That's what we will be learning starting class 3-4. So the next week, we will start learning on how to create business rules. That would be a first introduction to business rules. The next step, we create a database model using the business rules or entity relationship diagrams. So entity relationship diagram is a database model. It's a high level concept because it doesn't have a lot of details, but that is the first high-level prototype of our database. That's what we will be doing in class 4 and 5. We will be creating entity relationship diagrams. Further down, we will adjust those entity relationship diagrams and create logical design based on the entity relationship diagrams, because again, entity relationship diagram is a high-level concept, high-level model. So further down, once we add more details to entity relationship diagram, we'll create a logical design. And as a result of logical design, we will define our future data tables. That's what we will be doing in week 6. Then, as a database designer, we will need to select database management system. Again, it's a lot of different database management systems on the market. For the purpose of this class, we will be using using SQLite, which is a really simple database that is designed for schools. So there's also different other software database management systems. There's SQL Server, MySQL, Oracle, and so forth. And those are two of those are paid versions. SQL Server and Oracle and MySQL is a free version. But again, like for the purpose of this class, we will be using SQLite. Once we made a decision on what kind of database management system we will be using, we are ready to implement the database. In other words, create tables, load data, and so forth. That is what we will be learning in class 7, when we will be learning about SQL. So creating tables and loading data is part of our SQL class. Once you set up the data and you create the table, you are ready to set up a security. Very important part of creating database. It is not covered in MIS 380. So if you're interested in the database, you can take a high-level class that talks about database development in detail. So that's where you'll be defining user roles, data encryptions, and other high-level concepts required for the database. Further down, once we have our database, set up security, we use our database to we ensure that performance and data integrity is in place. We will be using our database in class 8 and 9. When we'll be writing SQL and advanced SQL. So further down, we will learn how to connect our application to the database, uh, or how to use our database online. So we'll talk about database connectivity, why database connectivity is important, and how to connect to our database from application. So that would be covered in class 10. You will also have that as part of your team project. And once we have our database, here comes the database maintenance that includes testing specific database for certain criteria, looking at performance, creating indexes, making sure that our retrieval routines are optimized, stuff like this. And we will cover indexes and performance of the database in class 11. So as you can see, we in this class we will be dealing with all the aspects, starting from creating database to starting from the very high level design to creating database to using this database to improving performance of the database. So that is why this class called database management systems, because we will be creating and designing database management systems from scratch, and we will be going very slow through this process, so you'll have an exposure to every single step. And just like we talked during the last first lecture, there are people behind every specific step of the database management system creation. So database designers design the database or create models for the database. Database developers deal with already existing database, developing different access routine or different SQL queries, and database administrator who helps to maintain the database. So they are responsible for improving performance, creating indexes. They're also responsible for defining user roles and stuff like this. So again, there is a specific position or specific job behind every step of creating and using a database management system. Um, so first, create database model and create logical designs. Those are part of DBMS design. That was a question that was asked during my in-person lectures. So I decided that I'm gonna put a little more details for you guys here. Okay, so let's talk more about database management system design. So design is a very important part of creating database management systems. So, in this case, we have an example of employee skill certification in a poor design. So, why it is poor design? Let's put this video on hold and let's think a little bit here. Let's look at the data and see what issues do we have with this specific data. Right. I hope you guys have your answers. So now let's analyze. Well, first of all, we can see that there is an empty rows for line 9 and 10. What does it mean? We don't have any names here, however, we have skills. So do those skills belong to employee 8 or do we just miss the data here? So that's question number 1. So how do we how do we produce alphabetical listing of employees? Um, can we do that when we have empty employees? Do we need to fill out the gaps? So we don't know. Again, like this is a design, but is it a good design? Probably not. So how do you count how many employees can have basic data manipulation skill? So basic data manipulation skill is listed um, only, it's not listed here at all. So again, like, I mean, you can answer this question. So um, now, is basic database manipulation and basic DB manipulation the same thing? Is it two different skills? Again, like, I mean, we don't really know if that's the same skill or not. Is it manipulation or is it management? We also don't know because of the data inconsistency. Again, and there is more issues. Again, that is not a good design. Why? Because multiple different concepts are presented in this example, and those multiple concepts must be part of a different data tables. So the way we improve this specific design, we can create three different tables that represent the same data but in a structured format. So we can store separate employee information, then we can have separate skill information, and then we can have a table certified in between that allows us to link skills to employees together. Okay, so that is an example on how this poor design can be improved in a good design. Again, I mean, with this good design, we don't have data inconsistencies, we don't have empty spaces, stuff like this. So this example is to show you that it's very important to properly design data table, and that is why we spend a lot of time working on the database design. So we talked about the databases, we talked about the database components, we talked about different types of the database, we talked about database design and why it's important. So those are advantages of database management systems. So they're pretty much the same as disadvantages of the file systems, and all of those disadvantages of file management systems are solved by introducing a database. So with database management system, we have improved data sharing, data security, better integration. We have consistent data, so very minimum data inconsistency. We have improved data access for decision making, and we have an increased end user productivity. So there is much more advantages of the database management system, but those are the main one. Now, but if their database management systems are so good, why don't we use them everywhere? Well, there is a very good reasons for that. And here is a little shift in focus that, or a different opinion, not opinion, different view of the database management systems that I wanted to present you guys for further thoughts. You can read about that in your book, but there are also reasons why database management system is not solution for everything. Database management systems are expensive. So for the example, one license for production server for SQL Server 2016, which is not latest, but I think the latest is 2022. So one license for I think uh, supporting no more than 1 terabyte of data cost about 20,000 a year. It's a lot of money, even for business. So database management systems are expensive. Oracle is even more expensive. So increased costs. So in producing database management system and increase business cost. Again, some database management systems are free. For example, MySQL, but there is not a lot of support available for MySQL in the industry. That is why companies primarily use the database management systems that do have support and provide support agreements. So companies like Microsoft with Microsoft SQL Server, Oracle, provide full-blown support to its customers. That's why people pay for license. Okay, increased cost, management complexity. So once you have a database management system, you usually need to hire more people. So it would be not easy to manage a full database management system. Maintaining currency, so you will need to have all the system up to date. You need to make sure that you apply patches, version, stuff like this. So that is a responsibility of database and database administrator along with system engineer. for DOS page application. So vendor dependence, we will talk more about vendor dependence in the future, but once you select the database management system you want to go with, you will be married to this database management system for life unless the company is willing to invest into redesigning software to work with a different database management system. Transition from one vendor to another is very difficult. Um, Frequent upgrades, replacements, stuff like this. So, for example, I can tell you that my team is currently using SQL Server 2016. We need to upgrade to SQL Server 2022, and this upgrade is very risky and lengthy. So, while we decided not to frequently upgrade, right now we are seeing the consequences. So again, in order to properly maintain database management system, you need to make sure that you're on top of it. You frequently upgrade, you replace your software with a new software, stuff like this. So again, expensive maintenance. And That's all I got for this lecture. So hopefully it was interesting and productive. I strongly suggest you guys review the lecture material again. And that's it for today. That's it for this week. If you have any questions, I would love to hear from you guys. I'm going to post a discussion on the discussion board. And the homework for today is to read chapter 2 today's lecture and read chapter 1 today's lecture and read chapter 2 to prepare for the next class. So that's it for today. And I'll talk to you guys next week. I hope to hear from you if you have any questions. And if not, please complete first quiz, introduction quiz, by the end of this week, Sunday. Have a great rest of your week. Have a great weekend, and we will talk next week. Next week, we will be uh, learning about managing data in organization. And during this lecture, we will have first set of materials that you guys will need for your homework one. Right? Have a great weekend, and we'll talk next week.